Here we go, the Chapter 5, Section 3 screencast for names and formulas of ionic compounds. This is often a difficult concept for applied chemistry students in the past, so I think this screencast and presentation will be very helpful for you. So here we go. We're going to talk about simple ions, the ionic bonding and the salts that are a result of that, and then how we name them and how we write the formulas. So you're going to be able to name cations, anions, and ionic compounds. You're going to be able to write their formulas and explain how the formulas relate to their names. So binary indicates that the compound is made up of just two elements. And in order to name a binary compound, you have to follow the rules. So there's simple rules for this. To name cations, cations are named mostly just by naming the element and then ion after it. So potassium would be a potassium ion, right? But if it has more than one possible ion that it forms, namely transition metals do this, then you have to add a Roman numeral to indicate the charge, right? Because it would be very confusing if you just said the copper ion. Nobody would know necessarily which copper ion you are referring to, if you're copper 2 or copper 1, right? Copper 1 compounds tend to be green, whereas copper 2 compounds tend to be blue. And so they're different, and you have to name them differently. And so this anion is super easy. It's always, the name of anions is always "-ide" at the end of it if it's a simple monoatomic ion. And so I created this little flow chart for you to help you name monoatomic ions. So if it's the atoms of metal or nonmetal, then you go this way or that way. So if it's a nonmetal, then you change the ending to "-ide." That's it. Nonmetals always form negative monoatomic ions, and so that makes it nice and easy, right? Chlorine becomes chloride, fluorine becomes fluoride, so on and so forth. For the metals, now you have possibilities. So if the metal has more than one possible charge, then you have to add a Roman numeral. But if the metal does not have more than one possible charge, you just name the element. So then naming the binary ionic compounds is just combining those two names together, right? You just combine the name of the cation followed by the name of the anion. So NaCl is sodium chloride because that's a sodium ion and that's a chloride ion, right? Copper 2 chloride, that's a copper 2 ion. It's a chloride ion, right? Easy peasy lemon squeezy. Now, writing formulas, you have to have a balance of the positive and negative charges, right? So they have to add up to 0. That's the whole idea behind writing the formulas, is that the charges add up to 0. And so with sodium, you would have a 1-to-1 ratio, right? You would also have a 1-to-1 ratio with zinc sulfide, right? Because zinc is +2, sulfide is -2, and then that's how you figure that out. So sometimes it's different, right? Magnesium is +2, nitride is -3. So if you're making magnesium nitride, you were writing the formula for that, then you'd have a difficult time, right? Because you'd have to make sure that you balance out those charges, and it's not just one magnesium and one nitrogen. So how do you figure it out? Well, your textbook has a way to show it to you by using the lowest common multiple between the numbers. So the lowest common multiple between 2 and 3 is 6. And so you would need 3 magnesiums because 3 times 2 is 6, and 2 nitrogens because 2 times 3 is 6, right? The 3 is down here and the 2 is up here, right? And the 2 is here and then the 3 is up here. So that's what I'm talking about there. But I came up with an easier way to do it. Okay, so I have a crisscross method for writing formulas. And so you take the charge and you boom, you put it down here as a subscript. You take that charge, put it down here as a subscript. And when you do that, you'll see that you still have the 3 magnesiums times +2 is +6, and 2 nitrogens times -3 is -6, +6 minus 6 equals 0. So it's the same thing as the other way, but I like to do it this way because it makes it easier, in my opinion. But it does the exact same thing. Polyatomic ions are, just like the name implies, they are ions that have more than one atom, right? So they're polyatomic. It's a charged group of 2 or more bonded atoms that considered a single ion. You'll see a bunch of these, Okay. Here's a little illustration of what atoms look like bonded together. I don't know why that's in there. But here's the other ions, right? So you have sulfite right here, SO2 or SO3 with a -2 charge, and sulfate, SO4 with a -2 charge. And so the way to figure out the formulas from the names can be kind of complicated. So we're going to spend some time on it in the PowerPoint here, and you'll want to read through this to get all the answers there. Um, it's really, it's a really helpful resource for you. But more helpful than that, I think, is Hank Green, who explains how to speak chemistry and how to name acids and using ions and all that kind of good stuff. It's really helpful. At the end of the video, he has this chart, right? And this chart is, I think, very helpful for you to figure out um, polyatomic ions and their prefixes and suffixes and what that means for the name of the ion. So, when you're naming compounds that have polyatomic ions in it, it's super easy. All you have to do is name the cation. Remember how to name cations. And then you name the anion. And all polyatomic ions have a name, right? And so you just use the name for that polyatomic ion. So here's some practice problems. That's the end of the whole guided notes part. You should be able to fill out everything in there because if you go through, salts are made of simple cation anion known as binary ionic compounds, right? The adjective binary indicates the compound is made of two elements, right? So on and so forth. You should be able to figure that out. But the rest of the PowerPoint is a bunch of questions to help review for you. So you should do those because it helps you understand.